Now, for the test for the validity testing of our questionnaire as a case study, we are going to be discussing it under a topic called reliability testing. Now, for you to be able to carry out any research, it must be valid and reliable. If it is valid, definitely it's going to be reliable. And that's the reason why we are doing reliability testing. Now, whenever we administer a questionnaire to respondents, we would like to know how much of their score reflects true and how much of them reflects error. It simply means if a research instrument is able to dictate true that are true and not error, then we can say that that research instrument is reliable. It is a measure of reliability that provides us with an estimation of valid variation due to true difference among respondents on the attributes being measured by the test. When a test is reliable, it provides dependable, consistent results, and for the reason, the term consistency is often synonymous to reliability. So it means consistency means reliable. Anytime there's a reliable, anytime we have a reliable result, it means the answering of that question by our respondents have been consistent. Those who don't know or don't have a knowledge, we fail the questionnaire, and those who know, we pass. That's when we say it's reliable. Now, the percentage of this reliability over error is now what we now call the reliability coefficient. Now, there are several ways to estimate reliability. However, each involves assessing the consistency of respondent score over time across different scorers. So if we have different people who will mark a questionnaire, then it must be consistent. Different people marking the same questionnaire answered by the same group of people, they should be able to give out the same inference or the same conclusion on that questionnaire. And the common assumption of each of these reliability techniques that consistent variability, that's the variability among each respondent answering the questionnaire, equals to true score variability. While variability that is inconsistent, those that is not really measuring the knowledge or not measuring the factor being measured, is inconsistent. It just reflects random error. It just means maybe a respondent really did not know, and this states the fact that he did not know or leave it. What he does was just to pick one. Now, by just picking one, it has not tested his knowledge. So it may not be consistent with other respondents. And in that case, we can see that that questionnaire has not really tested the knowledge of that respondent, and it cannot be used to answer our research questions. Now, the reliability coefficient is, in normal times, in estimating reliability coefficient is produced, which is a correlation coefficient that ranges from 0 to 1. It simply means, in simple terms, it simply means that coefficient or the variation in how people answer, different respondents answer that questionnaire during a pilot study the variation is being measured in a coefficient that can be measured between 0 to 1. And you may wish to note that questionnaire, not questionnaire, I'm sorry, I beg your pardon. Pilot study, most of the time, pilot study being it's not a full research, but it's a pre-research of the whole research. It's a mini research of the whole research. It usually used to be 10% of your intended sample size. So if your intended sample size, after your sample size calculation, which I feel must have been done in basics of research, is 100. So you just have 10% of that 100 as for your pilot study and see what the outcome will look like. So in most cases, it used to be 10% of. So when a test reliability coefficient is 0, this means that all the variability in obtained test score is due to measured error. Conversely, but when the test reliability coefficient is +1 or so, this indicates that the variability score is reflect true variability score. Now, Cronbach's alpha is, as we said earlier, there are many methods of estimating reliability coefficient, but Cronbach alpha is one of the frequently used tool in reliability testing. And don't forget that reliability equals validity. It's most likely if you have a very reliable research instrument, then definitely we can say that you have a kind of valid research instrument. Now, regardless of this method used to calculate any method, Cronbach's or whichever method you are using, a reliability coefficient is interpreted directly as the proportion of variability in obtained test score that reflect true score. Those who pass truly pass, those who fail truly fail. Not that those who pass guess and through error they just chose one, or those who fail just guessed and pass. So it's not, it wasn't testing their knowledge. So basically, I think that's what we have in today's exam in Nigerian education. It's those who pass really did not pass, may not have passed. You just see somebody just choosing anyone just like that, and he may get it right. His knowledge has not been tested, but he got it right. He got it right. So before an exam, for those who are in education sector, before an exam, we can get 10% of the total number of students to be examined and test with giving a pretest and in a different way. So I do not have a score of the main exam, but in a different way, just to test their knowledge. That if that exam is really testing their knowledge on the topic, and yeah, you'll be able to know whether yes, it's going to test their knowledge, or that research or that exam is really an instrument to test the knowledge or not. For example, a reliability coefficient of 0.84 indicates 84% variability score and is due to true score difference among examinee, while the remaining 60% is due to measured error. Now, for the purpose of this class, we are going to be using Cronbach's test of reliability as an example on SPSS. Now, this is how we go about it. Now, I'm going to share just a questionnaire. It's not really a questionnaire like that. It's just, I just prepared it just now. I just prepared this just now. And I just want to share it with you. This is it. Yes, this is it. Now you can see, let's assume this is a questionnaire to test for people's knowledge of whether they know what COVID-19 is or not. Now we have 5 of it, 5 questions. It might be more than this, but I'm just testing. So let me say my sample size is 100 and I give it to, or let me say my sample size is 10. Okay, let me say it's 100. Let me say it is 100. Let me say it is 100 and I gave it to 10 people. Gave it to 10 people. Gave it to 10 people. So I will go to my SPSS. I'll go to my SPSS. For those of us who have SPSS, this is how it looks like. I'm sure in data analysis, they're going to be talking about this, but I'm a data analyst. It won't be of good if I don't talk about validity or reliability of research instruments in research design. Basically, it is a data analytical tool in research design, and it won't make sense if I don't talk about it. So, if these are SPSS, and we have 5 questions, if you can remember from our questionnaire, we have 5 questions. We have 5 questions. You can see 1, 2, 3, 4, 5, and I gave it to 10 people. My intended sample size is 100, and I gave it to 10 people to fill. Now, those who pass, if they get the correct answer, I give them 1 mark. If they fail it, I give them 0. Now, Cronbach's alpha, I want to take the consistency of all 10 people and now see if they really got it right. So this is how we're going to go about it. 5 questions. Let me go back to my SPSS. Okay. Now, let's assume V. So, if this is our SPSS, so without, just to make it very, very easier for us, you can just state that this is our 5 question. 1, 2, 3, 4, 5. So you can see for those who score. So variable 1, 2, 3, 4, 5. Let's assume so. First person, got the first question right. I give him 1. Failed the second question, got the first one, got the third one, failed the second one, failed the fifth one. Now, the second person scored the first one right, failed the others, and now got this one right. This one got everything. We are going to 10. So this one failed the first one, failed the second one, failed the third one, and got the remaining 2 right. This person got all right. This one too got all right. This person got all right except the last one. This person almost got everything right except the last one. This person got all right. This one got the first one, got the second one, failed this, and now got the last one. So these are 10. Let's say this is. So basically, let's say this is how the outcome of the, after marking everything, this is how it looks like on whether they have knowledge of COVID-19 or not. Let's say this is how it looks like. Now, how do we now detect whether we have a very good? So this is how we run Cronbach's alpha to detect whether our questionnaire have really been testing the knowledge indeed or not, or we need to modify our question, or whether the respondent did not understand the question. So those are the steps you take after running your Cronbach's alpha. So the first thing we analyze, we click on analyze, we come down to scale, we click on scale, click on reliability. Then we now inserted all the variables. Variable 1 to 5, we insert it. This one, we click on it, we insert. We click on it, we insert. We click on it, we insert. Click on it, we insert. We click on these statistics, and we now need to click on some items. So we now check all these 3 items, the item, the scale, and the scale if item deleted. We click on continue and continue, yes. So it will pop up this information at the output. Now, this is our variable. This is where we check first. These are our results. Now, this result is stating that we have a 0.67 Cronbach's alpha. Now, 0.67 is not good because we must have a benchmark of between 0.7 or 0.8 to be able to say that, okay, that our questionnaire has been reliable in determining the knowledge of people, knowledge on COVID-19. So what we need to do is just make an adjustment. And once we make an adjustment, we can check this. We can check this box, this table called item total statistics. In items total statistics, it simply means that if we delete, you can see this last one here. Cronbach's alpha if item deleted. If we should delete question number 5. Okay, let me start from the first one. Question number 1, if I delete it out of the 5 questions, I will be left with a Cronbach's alpha of 0.61. It's still not good because it's not up to 0.7. If I deleted the second one, leaving the remaining 4, we are going to have a Cronbach alpha of 0.4. It's even worse. So we leave it if we continue. But if we check question number 5, the moment we delete that number 5, the 5th question, the moment we delete it, we are going to have a very high Cronbach's alpha. So what I now need to do, this Cronbach alpha is now up to the benchmark of between 0.7 or 0.8. Now you can see we have 0.8. So it means I'll just go back to my questionnaire. I'll go back to my questionnaire. And where is it? And I'll do without question number 5. Do you need to wear mask in a public place? The way people answer that question has caused our Cronbach alpha to be low. So what I need to do is to modify it or to delete it entirely. So this is how to run Cronbach's alpha on SPSS. And Basically, I hope this helped. Thank you for listening. I remain myself once again, Abdulaziz, and thank you for listening.